So, what is the electric power? And how can you be able to express the electric power mathematically? Let's say we have a circuit. Now should be, let's say this is a circuit where we have this one as the switch. And that one is the voltage, source of voltage. Should be the source of the voltage, like that. And let's say this is the bulb. Let's say that's the case. And let's say the bulb is of, let's say, a resistor giving us, let's say, R. That is the resistance of the bulb. Assuming that's the case. And this is a battery with a potential difference given as V. That is the voltage or the potential difference. You understand this is the switch. So now, if we close the switch, the current will have to flow in that way. Let's say that's the case. This is the current flow given as I. So, what is the electric energy dissipated across the bulb with the resistor given as R? So now the formula for the electric energy is given as U is equal to, now the amount of charges that are flowing within the wire given as a Q, and it times the potential difference which is given as V. That will be the electric energy dissipated across the resistor R, where the potential difference V is the voltage across the resistor, or actually should be the voltage across the battery, actually the voltage across the bulb with the resistor given as R. So that is. So now, let's think of dividing both sides by D. So which means we'll have D in this case, or have D in this case. So if that's the case, then the energy divided by the time is said to be the power. So the formula for power is given as, should be, the formula for power is given as the energy divided by the time. This is the formula for power. So what is the electric power? Now, since we are dividing the electric energy by the actual time, it means we'll have it as, this is now the electric power that will be given as, now this is the same as the amount of charges divided by time, and times the potential difference. And it actually, and of which from the definition of the current, which is said to be the rate of the flow of the charges per unit time, it means charge over time is the same as the current. Hence, we'll have the electric power being given as the current times the voltage. So this is the formula for the actually electric power. So if we have the flow of the current, and if we have the source of voltage, that is, if we have the voltage across that particular actually a component, then the formula for power is given as this. So this is the origin of the formula for the electric power. So now, according to the Ohm's law, we know that the current is given as the resistance should be the voltage over resistance. It means if we substitute this current onto this point, it means the actually the power will be given as now V square over R. Now this is also another formula for the electric power. So that is, and also from the Ohm's law, we know that the voltage will be given as a current times the resistance. It means the power will be given as now a current square times the resistance. If we substitute the voltage onto this point, we'll have I and I multiplying, that will give us actually I square in times the resistance. So that is also another formula for the electric power. So if we have the resistance of a component, and we have the current flow, can be able to have the electric power using that formula. So which means the electric power has got the following formulas. So have that, and also have that, and of which you also have it in this case. So take note of that. So now let's say we have this question which says that a handheld electric fan operates on a 3.00 volts battery. So which means that's the voltage. So that is 3.00 volts. Now, if the power consumed by the fan is given us, now this is the power. We have it as 1.77 watts. By the way, the basic unit for power is given as the watts. So now, what is the current supplied by the battery? So we are looking for the current. So we have three parameters. That is the voltage, power, as well as the current. So what is the formula that is connecting the three parameters? So which means we use the formula which is given as the power is equal to the current times the voltage, of which the current has to be in amps. So try to have that analogy at your own. That is at your own time. And let's say we also have this problem. A battery that produces a potential difference V, that's the potential difference, that's the battery, and I'll have it as a V, is connected to a 5 watt light bulb. That is the power given as the 5 watt bulb. So it should be a 5 watt. Now, later the 5 watt light bulb batteries should be a 5 watt light bulb is replaced with now a 10 watt light bulb. So by the way, we have the voltage as well as the power. What is the current for this case? Let's say this is the this is the initial power. Let's say that's the case. So now, which means we'll have the power is equal to IV. So in this case, we'll have the initial current. Since this is the initial power, so we'll have the initial power being given as, it's now being given as, so now the initial current will be given as the initial power divided by the voltage, of which the initial power is given as 5 kilowatts divided by the voltage. So this is the initial power. Should be, that is the initial current in that case. So that is the initial current. And since we have the initial power given as 5 watts and the battery is having the volts given as V. And now that is the initial current. So the next, later the 5 watt, actually the 5 watt light bulb is replaced with 10 watt light bulb. So now, by the way, the battery remains the same. So which means now what will change? We'll have the final power. So what will be the final power? We'll have it as the final current times the voltage, of which the final current will be given as the final power divided by the voltage. What is the final power? We'll have it as 10. So have 10 over voltage. So over voltage, of which this is the final power. So now the question says that in which case does the battery supply more current? So between this and this, where is the more current being supplied? So obviously this is the case, because the numerator is 10, while here the numerator is given as 5. In that case, we'll have the more current in the actual second case, which is the case where where the power is basically more, because the power as well as the current are directly related. So if the current increasing, it means the power is also increasing as well. That's the principle behind. So which light bulb has the greater resistance? What is that one? So you have to understand that the power is given as, no, should be what? So you have to understand that the power is given as the V square over R. So if the resistance increases, it means the power will be reduced. If the resistance decreases, it means the power will be increased. So in that case, the bulb with the less power, it means resistance is high. The bulb with more power, it means the resistance is low. So in that case, the light bulb with the 5 watts, it will be the one with greater resistance. So take note of that. And what if you have this question? And now we have this question that leads a battery with EMF of 12 volts. So that is the voltage given as the 12 volts. Is connected to 54 ohm resistor. That is the resistor given as the 54 ohm. So how much energy is? So we're looking for the electric energy, and in should be now 6 seconds. We have the time given as 6 seconds. So what is that on? We know that the electric energy is given as the actually electric power should be now, in this case, we know that the electric power is given as the electric energy divided by time. So which means electric energy will be given as the electric power times the time. This is the analogy. This you should have to understand. So the time we are deriving the formula for the electric power, we said electric energy is given as the charge flow times the potential difference. If we divide both sides by time, what we have here is the electric power. So which means the electric power is given as electric energy over time. So which means the electric energy will be given as the power times time. So that is the principle behind. So take note of that. So which means the electric energy will be given as the electric power times time, where the time has to be in seconds. So what we are looking here is the electric actual power. What is the electric power? So using the parameters that we have, voltage as well as the resistance, so have it as VR over resistance. If we have that power, we'll be able to have the electric energy. That will be given in joules. By the way, the basic unit for actually energy is actually joules. So have that on. And also let's try to go through this kind of a conceptual question. A light bulb, actually a light A has 4 times the power rating of a light B when operated at the same voltage. So we are sure that the power rating, it means the power for light A is said to be 4 times the power for light B, and assuming that the voltage is the same for all. So the voltage is the same for all. So now, is the resistance of the light A greater than or less than or equal to resistance of light B? So we know that the power is equal to V square over resistance. If the resistance is increasing, the power decreases. If the resistance is decreasing, the power increases. So which means the light with more active power means it is having less resistance. So in that case it means you should have to know that actually the resistance of a light A is less than the resistance of light B. So that is. So the other question says that what is the ratio of resistance of light A to the resistance of light B? So what is the power for light A? The power for light A will be given as now V square over RA. This is the resistance for light A, where the voltage is given as V square. And what is the power for light B? We'll have it as V square. Since it is the same for this one, we'll just have to literally have it as V square over now RB, which is the resistance for actually a light B. So now we are sure that the two actually powers are rated in the sense that PA is equal to 4 times PP. So which means we'll have it as this. So which means we'll have it as now V square over RA is equal to 4 times V square over RB, of which these are the same. Then we have 1 over RA is equal to 4 over RB. So let's think of cross multiplying in the sense that we have it as RB is equal to 4 times RA. So that is, so now which means the ratio of resistor for actual light A will be given as, let's think of dividing everything by actually RB. So which means we'll have 1 is equal to 4 RA over RB, of which you have it as 1 over 4 is equal to RA over RB. So that is the ratio, of which you can be able to express that one in terms of of course that is in fraction, but the ratio will be given as 1 to 4 is equal now RA to RB. So that is the ratio, and of which it is really making sense, because as it stands here, it means resistor for light B is 4 times the resistor for light A, of which the resistor for light A is 1/4 the resistor for light B. So which means the resistance for light A is much less than the resistance for light B, and which is led true for light A to have the more actually a power. So that is, so using the same analogy, let's try to understand the other upcoming question. So now using the same actually a principle, let's try to go through actually this problem. Two light bulbs operate on the same same potential difference. So that is, a light bulb A has 4 times the power rating of bulb B. Which bulb has the greater current passing through it? And explain. So the power for actually a bulb A is 4 times the power for bulb B. So which means this one is having more power compared to this one. So What is the relationship between the powers as the current? So the relationship is the direct relationship, which means the more current is, the more power is. So which means the one with the with a more current passing through, it is that of a bulb A. So what is the ratio of the current in bulb A to the current in bulb B? So since the relationship is between the power of voltage, that is the potential difference as well as the current, so which means the formula for power will be used as the power for A is given as IA, since the voltage is the same, and the power for B will be given as IB, the voltage is the same. So we'll have to substitute this for this one and do the same way we did it before. So try to have that one out. In our final rates, just have to finish up with this problem. Calculate. No, it should be this. What is this question? So I should have to remove this one. So this one should not be there. So now a 65 watt radar battery should be I don't know what is happening, but should be a 65 watt light bulb. So we have the actually should be the power there. So that is the power. So this is the power given as 65 watts. Operate on a potential difference of, we have the voltage 95 watts. So now find the current in the bulb. So we're looking for the current. So of which the current, the formula power is equal to IV. So the current will be given as the power over voltage. So you'll be able to have the current there. And B, what is the resistance of the bulb? We're looking for the resistance. So since we have the power, V square over resistance, it is fine. Or else we can have power is equal to I square R, that is fine. Or else the formula for the ohms, we can be able to have the resistance of the bulb. So see, if this bulb is replaced with one whose resistance is half the value found in part B. Now let's say the resistance of the bulb has been halved, which means has been reduced now. So is its power rating greater or less than 65 watts? So now since the resistance has been decreased, it means the power will have to increase. It will be basically greater than that one, and I can be able to have the power factor, that is the ratio in which the power will be affected, the way we did it for the two previous actual equations. So that's all you have to understand about the electric power as well as the energy. So thank you.